So some of you guys said, all right, that there's Mario's, and yes, wondering if it's geometry related. Someone said it's rotating. Mario is rotating at different angles in each quadrant. Ooh, quadrant, I like it. I like it. You're using the vocabulary, so there you go. Quadrant, rotating. Ooh, that's another one. That's another word. They're all in different quadrants. Ooh, here we go. Keyword again, quadrants. And I wonder why they're all Mario. Well, I can answer that for you. Why not? Right? Mario. We all love Mario. Mario has been part of like all of our childhoods and stuff. So why not? Why not Mario? I was going to put Bernie in there, but I know it's been like 2 or 3 weeks. So some of you are like, oh, mister, that's old. So Mario's classic. So that's why I use Mario. I noticed that the Mario figures are going counterclockwise. Nice. And I wonder if this is what we are going to learn about today. Maybe. That Mario is on the picture, and I wonder if he likes math. I think he loves math. I noticed that they reflect across. I wonder why. So they said reflect. That's a key word. So some people are saying rotating. Some people are saying reflecting. We'll talk about that. Which one is it? Is it both? Is it one? Is it neither? I noticed that they are all facing different directions, and in every picture they rotate to a different position. I wonder if they are meant to be different in every picture. I noticed that they look like they are all in the spot, and I wonder if they really are. I noticed that there are four Marios in the graph. Okay, good. I noticed 4 fat plumbers, also known as Mario, and I'm wondering if it's April. Wait, what? I'm confused. I noticed 4 fat plumbers as Mario, and I'm wondering if it's April. Well, you think it's April Fool's? You think I'm fooling you or something? That each picture is facing a different direction, and the character looks like they're all turning left motion. I noticed Mario being reflected along the X and Y axis and rotated. So this person says reflected and rotated. Okay, so they think both. Where is the line of reflection? And there are multiple Marios. Okay, why is my graph stuck? Oh, good Lord. Sorry, guys. My page froze. Okay, I think that's it. Okay, there we go. I wonder if it's April. I noticed Mario being reflected along the X and Y axis and rotated. So this person thinks they did both. Where's the line of reflection? And there are multiple Marios. There's a character from Nintendo called Mario, and I wonder why he's in this warm-up. Okay. Each Mario is either reflected or rotated between each other, either the X axis or Y. What I wonder about this picture is why is Mario in the graph? Okay, why is he there? Again, I could have put a triangle there. Boring. I could have put a rectangle. I could have put a basic shape, but I put Mario just for fun. So we kind of have a controversy here, right? We have a controversy here. Is he being reflected or is he being rotated? So if we look here, there's first of all, I like quadrants. You guys know what quadrants are? You guys know what quadrants mean? Quadrants mean the coordinate plane cuts all these into 4 areas, right? And each of these areas is a quadrant. Get it? Quad means 4. So you have 4 quadrants. They actually have names, and you don't have to memorize this, but they do have names. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, and they're rotating like that. Okay, so that's usually how we rotate. We when you go to trigonometry, you're going to notice that we look at them. If you notice, it goes 1, 2, 3, 4. It goes in that direction, right? And why does it do that? There's various reasons, but That's the direction we go. And then somebody said it in here. Someone said, what direction is that? Going in that direction, going from here to here. What was the key word we heard? Hello, anybody?
Bueller.
Anyone? What direction is that called? Anybody? Wow.
Counterclockwise.
Counterclockwise. Thank you. That's counterclockwise. Someone said that in the warm-up too. And I know you guys are young, so maybe you've never seen a clock like this, because it's every year it's shocking to me when I show kids a clock like this, right? And they can't tell the time on a clock like that. So if you can't tell time, it's okay. I'm not going to test you if you can tell time or not. But if you notice, the hands go in this direction, and the hands go in this direction, that's called clockwise. Okay, so if we go in the other direction, the opposite direction of the way a clock works, we call that counterclockwise. Right? And that's usually the direction we go. In math, on the coordinate plane, we like to go counterclockwise. We can go clockwise. I mean, we can go from this Mario to this Mario, but that's usually seen as backwards. Usually counterclockwise is forward. That's how we go. And when you go in trig, you're going to see that. That's the direction we usually go. All right, so you guys did see some vocabulary, but we didn't answer the question, is Mario being reflected, rotated, both, or neither? So what I did is I went high tech and I printed out a Mario, right? And so here's my Mario, and then let's think if we want to reflect him. If we're going to reflect Mario, we need a line of reflection. We need a line of reflection. And so there's my line, my Apple Pencil, and then there's Mario. And if he's reflected, he's going to go like this. He's going to flip to the other side, and I know you can't see it, but he's facing the opposite direction. So over here, he was facing this way, and then if we flip him over, he's facing the other way, right? His arm's on the other side. And if we look at our picture, it kind of isn't doing that, is it? The arm, and I like to focus on this arm right here. This arm right here is facing the same direction. Okay, hold on really quick. Alrighty, sorry about that. So what do you think? It's not reflected, right? So if we look at this again, Mario, if he's reflected, he'd be looking the opposite direction. So this isn't a reflection. But is he being rotated? Let's think about it. If we go like this, and then we turn him like that, and we turn him like that, and then we turn him like that, and then back to the original, is that kind of what's happening here? Can you see that? Yes, we're actually rotating him. We're actually kind of, and I wish I had a string. So I kind of, well, I guess I have a wire. All right, so let's think about it this way, okay? So I wish my camera was higher up. So let's think about if I put a wire, if I put my finger down, that's the center, right? And then I get this wire and I connect it to Mario. So let's see if I connect it to Mario. And then I start if I connect it to Mario, and then I start swinging it around, you notice there's kind of a center of my rotation, right? It's kind of like thinking of I'm rotating it around a center. and think of a string holding on to it. Okay? So if we go here, I'm going to erase all this. I kind of made a mess on my picture. Because I want us to focus. I want us to see what's going on. Because somebody in first period, nobody asked here, somebody in first period asked, is Mario really a shape? Is that a shape? Or is it just a person? And I'm like, well, look at this. Isn't Mario a shape? It's not a basic shape. It's not a square, rectangle. It's a Mario shape. So yes, it is a shape. So what if I focused on a piece of this shape, right? Because remember, shapes are made out of a bunch of points. And so what if I focused on one piece, and I think I'm going to focus on Mario's thumb right here. Okay? And can you tell me the coordinates of his thumb? Of that thumb that's going up high? What are the coordinates of that thumb? Approximately, right? We're being approximate here. 4, -2. Very good. Yeah. So again, how do we do coordinates? We do coordinates. We start here. We have to go 4 in the x direction and then -2 in the y direction to get to that point. So the coordinates of this is 4, -2. Okay. So now let's look at this other Mario and let's look at the same point. Let's look at the same. There's his thumb again in that hand. What's the coordinates of that? What are the coordinates of that thumb? Well, if we look here, if we start at the origin, we have to go 2 in the x direction and then 4 in the y direction. So that is 2, 4. This was 4, -2. Then a rotation to the next one is 2, 4. All right, let's look at the thumb over here. The thumb over here is about right there. What are the coordinates of Mario's thumb there? Can you guys see it? What are the coordinates of his thumb there? Well, let's think about it. If we start at the origin, we go backwards 4 units and then up 2 units. So backwards 4 on the x, up 2 on the y. So backwards 4 means -4, and then 2 on the y, 2. And then let's look at his thumb over here. What's the coordinates of his thumb in that quadrant? Well, let's look. We went backwards 4. I'm sorry, backwards 2 on the x-axis, and then down 1, 2, 3, down 4 on the y. So we went backwards 2, down 4. What do you notice about the coordinates? I'm just following his thumb, right? We could also follow other points on Mario, but I just happen to follow the thumb because that's what I see the most. I see his hand sticking up, and so I see the thumb. And so everything's rotating, right? If Mario's rotating, that means every point on Mario is rotating, right? Just kind of like we've been doing. We did the translations, we did the reflections. We did it by points, and then we took the whole figure by drawing lines between them. Well, if Mario is rotating, that means every point on Mario is also rotating. It's going along with him. So, like we could have picked the button. We could have picked the button on his right here. We could have picked that button and looked at those points, but I just looked at his thumb. So do you notice something? Well, first of all, someone just said right now in the chat, they're all the same numbers. They're all the same numbers. 4, -2, 2, 4, -4, 2, -2, -. So they're all the same numbers, but they're doing something different. And the other thing, someone asked, hey, mister, someone asked in the chat, mister, which one's the original? Which one's the original? Does it matter which one the original is? Like if I told you this is the original in quadrant 1 and you rotate it, ooh, wait, how would I describe the rotation? Okay, let's say this is the original Mario and I wanted to go from this Mario to this Mario. How would I describe that rotation? Can you describe how I rotated it? That's the other thing. Well, okay. So here, some of you are like, Mister, I don't know. I don't know how to describe it. I'm lost. You're confusing me. What do I do? So that's timeout. Whenever you're lost, you're not 100% lost. I know what you guys know what rotation is, right? You guys know rotation. That means just spinning, right? Spinning. So let's think of something that we all do know. If I went from this Mario and I went all the way around back to this Mario, how would you describe that? I know you can describe that for sure. If I went from this Mario and all the way back to this Mario, you would tell me he rotated all around. Okay, give me a little more of a description. Something about degrees. Very good. How many degrees? Right? There's some skaters here. When you do a kickflip, when you jump up in the air and your board goes all the way around back to where it was and then bam, you land it. Oh, you just did a what? 360. Very good. Now, if you kickflip and your board only goes halfway and then you land on it, you did it only goes halfway. You didn't do a 360. You did a 180. Very good. So, very good. So, if I went from this Mario back to this Mario, that's 360 degrees. And if I go from, let's do a different color, from this Mario to this Mario, that's 180 degrees. So what would it be from this Mario to this Mario? Well, let's see. 360 is all the way. 180 is halfway, so 180 is half of 360. So if I go even halfer, is that a word? If I go half of 180, how many degrees is that? That's 90. Very good. Now, if you kick flip and your board goes 90, it's going to be facing the other way, and then you're going to have to move your feet to get back on it, but I guess you could. And here's my last question. What about if from this Mario, nope, I don't want that color. From this Mario and I rotate to this Mario, how many degrees is that? 45? 45 would be halfway, would be over here, right? But I want to go from this Mario past 180, but not quite 360. Right? I want to go from this Mario, from here to here is 90, from here to here is 180. What would this be if I stopped right here? If I keep going, it's 360. But if I stop right here, if I go 90, 180, and I stop right here, that's how many? Someone said 280. Ooh, so close. Let's think about it. That's 90, 90, 90. Right? Each quadrant is 90 degrees. How do you know? Because look, each quadrant is a right angle. You guys see that? What? Each quadrant is 90 degrees, and 90 and 90 and 90 and 90 is 360. Right? What just happened? Some of your brains, hold on, where is it? Right? So what would be 90 and 90 and 90? 280, somebody guessed. That's very close, but that's not it. 270. Let's go. 270. Very good. So that's a 270 degree rotation. So those are the three basic ones we're going to look at. We're going to look at 90 degree rotations, 180 degree rotations, 270, and we can look at 360, but 360 doesn't make sense because it's back in the same spot. It'll be back in the same spot. So that's the notes we're going to take, and we do have some new notes. So before we do that, are there any questions on what we talked about with Mario? Right? We learned a whole bunch of vocabulary. You didn't take a lot of notes, but you learned a lot. We learned quadrants, right? The quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. We learned going in this direction is how math goes usually on the coordinate plane. We like to go from quadrant 1, 2, 3, 4, which is counterclockwise. Ooh, that's another vocabulary word you learned. We looked at these points, and we noticed when I rotate, the points kind of look the same. Just a little bit of a change. They either flip or they change the signs, or both. Right? So we got to figure out, okay, there is a pattern. This is exactly what we do in math. We look for patterns. And so when we rotate, we're going to use this pattern to figure things out a lot easier and get our rotations really quickly. Okay, so and then we learned 360 is all the way around. So each quadrant's 90 degrees. So a rotation from here to here is 90. Rotation from here to here is 180. Rotation from here to here is 270. And then, of course, a full rotation is 360. That's a lot of stuff. That's good. That's a good starting point. If you understood all that, great. If you didn't understand any of that or some of that, please ask now. You have myself, Ms. Rivas, Ms. Preciado. You have all three of us here if you want to ask us questions before we move on. Because this was like basic talk. This is like a review. This is looking at stuff. Come up with some vocabulary, some pre-vocabulary words that we should know before we get into this. Any questions before we move on? If you're afraid to ask, again, go ahead and be afraid. Right? Dance with that fear, but still ask. All right. I'll still be here. If you have the question later, you can still ask later. So here's what I'm going to do. So we have our new packet. Let me show you again. I want to remind you every time because for some reason, sometimes you guys forget, and I get that. It happens. So what you're going to do is you go to Schoology, go to our course, period 14, click on that. And if you look here, wait a second. Give me 1 second. Technical difficulties. Please stand by. Mr. Pacheco is having technical difficulties. He'll be back with you in 1 minute. Please stand by. Okay, so I'll give you a minute to go ahead and do that. Okay, are we ready? We can start the notes. Yes, we're going to take notes. I know it took, you're like, Mister, you're silent for a while. I was just giving you a minute to go ahead and get those notes and get your handy dandy notebook. And so, okay, rotation. So I don't know if you've noticed, but we are going to rotate figures now. Now we're going to start really simple. We're going to rotate around, or as geometry people like to say, about the origin. That kind of sounds British, right? We're going to rotate about the origin, right? Why can't they just say around the origin? So we need to think of a rotation as imagine a string. So here's the origin. The origin is where you put your finger. Remember I was showing you that earlier? I had the string. Not a string, it's a chord. But I had a chord here, right? And that's my string. And then my finger was where the center was. And so anything I put on that string, like if I wanted to draw a circle, I can put my pencil on that string and just go like this around, right? Go like this. And so my finger's the center. So if we're thinking like that, then the center where my finger goes is going to be at the origin. That's what about the origin means. It means we're going to have a center at the origin. And imagine you putting your finger on that origin and a string going to each point and just it's going to rotate however many degrees they tell you. Okay? So if you imagine here, I put a string on C and then it's going to rotate that way and go to C prime. I'm going to put a string on B and then it's going to rotate over here along that string that many degrees. And the same thing with A. I'm going to draw a string from the center and I'm going to rotate to the new A prime on that same string. And if you notice, the angle is 90 degrees because that's a 90-degree rotation. So that's exactly what we're going to do. So what is a rotation? Let's get a definition. Right? So what is a rotation? Well, a translation was a slide. Remember, translation just slid left or right or up and down. Reflection was a flip. We flipped it over a line of reflection. And now a rotation is going to be, some people call it a spin, but it's basically a turn around a fixed point called the center of rotation. So we're going to do, our center is going to be the origin. So from now on, for this lesson, our center is going to be at the origin. That's going to be the center of rotation. So the figure rotates at a specific angle and direction. Okay, so we need to know, if we're going to rotate something, we need to know the angle we're rotating and the direction we're going. Okay? The direction is usually, it's not always, but usually counterclockwise. And the angle, for our purposes, we're going to keep it easy and keep it simple. Our angles are only going to be 90 degrees, 180 degrees, and 270 degrees. Okay? We're just going to do that. And 360, I guess, but 360 just takes you back to the original spot. So that's basically what we're going to do. We're just going to go 90, 180, 270, and we're usually going to go counterclockwise. Okay? If it says clockwise, if it says, "Ooh, I want to go clockwise," I'm going to show you how to change it to counterclockwise. Right? Because we can't just change and say, "Oh, let's just stick to counter." Because if we keep going back and forth, you're going to get confused. And if you notice, we had a pattern going on. We know something happens to these points. Right? Something special happens to these points. There's a pattern there. 4, -2, 2, 4, -4, 2, -2, -4. They kind of are all very similar, or they're switched, or the signs, there's something going on there, mister. And there is. Okay? And so this last sentence, though the figure can rotate around any fixed point, the most common center of rotation is the origin, right? Which is 0, 0 on the coordinate plane. And that's what we're going to do. We're going to rotate about the origin. Okay? This is where we're going to stop today. We're going to stop today. I just wanted to front load a lot of that vocabulary, what rotation is, what it looks like, a little sneak peek on the pattern of the points that do rotate. Something's happening there, and I think you noticed. You don't know exactly what, but looking at Mario, we notice something is happening with those points, that there's some type of pattern I'm going to need to learn. And yes, you're right. You're right. Okay, if there are no questions, we are done for the day, guys. Those of you that need to finish the quiz, you need to contact me so we can make an appointment during office hours. So you can do that. Those of you that need to finish the STAR Renaissance assessment, there was a couple of you that needed to do that. We will We'll do that tomorrow. We'll do that tomorrow because I know the website was down. We were going to do it yesterday, but the website was down yesterday. So we'll worry about that tomorrow. But those of you that didn't take it need to take it. That's a free quiz grade. And other than that, have a great day, guys. And I will see you tomorrow. Tomorrow's Friday. You guys know 3-day weekend, right? So tomorrow's Friday before a 3-day weekend. So no one's excited? Get excited. Get excited. All right, guys. Take care. I will see you all tomorrow. Take care. Bye. Thank you, Miss Rivas. Thank you, Miss Preciado. Appreciate it.
You're welcome.
You're welcome. Have a good day, everyone.
Someone asked me a question.